Hi guys, let's take a look at this question where we have an ambulance that is moving away from a stationary listener. So now there the listener is stationary, but the ambulance, the source, is moving. Right? So the source is moving with a constant velocity of 25 meters per second. The siren of the ambulance emits sound waves at frequency 550 Hz, and the listener detects the frequency of these waves to be 512,64 Hz. 6.1.1 State the Doppler effect in words. I would advise you to just study this definition, right? You get easy 2 marks. So the Doppler effect is the change in frequency or pitch of the sound detected by a listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Or the one that's probably most popular is, it is the apparent change in detected frequency as a result of the relative motion between the source and an observer/listener. Okay, 6.2. Use the given information to calculate the speed of sound of air. So we are going to use this formula. And I'm jotting down my formula because what do I want? I want a mark. I want a free mark here, man. Okay. So the frequency that the listener detects is 512,64. We want the speed of sound in air. The velocity of the listener is 0 because the listener is stationary, right? So that is plus 0. Again, I want the speed of sound in air. And then the velocity of the ambulance is 25. Then the frequency of the siren that the ambulance emits, or the frequency of the source, is then 550, which was given right there. So then I do my maths calculations to get V on its own. And I get V to be 343,04 meters per second. They will take a range between 332,14 to 343,4. Okay. If the ambulance moves away from the stationary listener with a constant velocity which is greater than 25 meters, so greater than what it is now, how will each of the following change? Increase, decrease, or remain the same? The speed of the sound of air, that will remain the same, right? That doesn't change. The frequency of the sound waves emitted by the siren, that will remain the same. The frequency of sound waves detected by the listener, that will decrease because the ambulance is moving away from the listener at a faster velocity. So the frequency that they will detect will decrease, right? The tone, the pitch will be less, right? And that is it, guys. See ya.